So
Okay,
we're moving to the next speech.
Yes, we have a great speech coming up. First, I would like to call on stage Holly Cummins and Georgios Andrianakis. Welcome.
Welcome. You can always scan that code to post your questions. Please don't forget to post questions if you have any for after the speeches. So
Yes, please. Holly Cummins is a senior principal software engineer on Red Hat Quarkus team and Java champion. Brings a wealth of expertise from her diverse roles at IBM, ranging from cloud consultancy to JVM performance engineering. A sought-after keynote speaker and author, Holly has harnessed cloud technology to tackle challenges like climate risk analysis, fish counting, and enabling solo ultra-marathon runs for a blind athlete.
awesome. And George Andrianakis works for Red Hat as a principal software engineer. He's the most active contributor for Quarkus, and he works in all sorts of areas, including but not limited to REST Easy, Reactive Spring compatibility, Kubernetes support, testing, and Kotlin. He's also an enthusiastic promoter of Quarkus that never misses a chance to spread the Quarkus love. Welcome, George. And the title of the speech is?
Leverage LLMs in Java with LangChain4j and Quarkus.
The stage is yours, Holly and George.
Thank you so much.
Hey, folks. Yes, I guess I need to mirror this. Displays, mirror. Excellent.
Thank you so much. Will you be around?
Hooray. So we're going to talk about LangChain4j in Quarkus. Before we start, sort of a quick check. How many of you have heard of Quarkus? A couple of hands. How many of you have heard of LangChain4j? A couple of hands. I think it was the same hands. How many of you are Java developers? More hands. So for us Java developers, I think until now, the progress that's been happening in LLMs is something that we've been kind of watching over the wall a little bit. And the LLM progress is kind of hard to keep up with. So when it's over the wall, it's even harder to keep up with. Have you, how many of you have seen the CNCF cloud native landscape? I think that's the same hands. So either you're the only ones who are not sitting on your hands, or you're really on top of things. Every time I look at the CNCF cloud native landscape, I want to cry a little bit. And because it's such a delightful experience to look at the CNCF cloud landscape, someone made an equivalent landscape for AI. And it looks like this.
Easy.
Which makes me want to cry even more. There's a lot of stuff in the CNCF landscape, and I think this one is even worse.
Oh, it's called MAD.
I know, and it's called MAD. Yeah. Machine learning, artificial intelligence, and data. MAD. And I mean, there's a whole bunch of things that are, for me as a Java developer, a bit of a problem with this. The first is just the scale of it. You can't read that at the back, because even at the front, you can't read it.
We can't read it at the front either.
There's so much, and it's changing so fast that even if this is your full-time job, you can't keep up with it. But there's another problem for me as a Java developer as well, which is that this is really dominated by Python. Particularly in some parts of the landscape, every single tool there is a Python tool. And as a Java developer, that makes me sad. Python is, hands up if you're a Python developer. A couple of hands. So now I'm going to get into a little bit of trouble here. I am not a Python developer. I am a Java developer. And when I try Python, it doesn't go very well. The absence of semicolons is okay, but the white space having semantic significance, it's just not good. So for technology that's kind of getting started, I think it's okay for it to be accessible only in one language. But once you get to the state of maturity that we're at now with AI and LLMs, it's not okay anymore that it's just for Python developers for all sorts of reasons, one of which is that they have really bad ideas and are terrible people. But just more generally, in terms of making the ecosystem inclusive, we need to go beyond that. So what we're really trying to do in my Red Hat team is enable developers, wherever they're coming from, but particularly if they're coming from Java, to take advantage of what's going on, to use these AI models. And to give a bit more context about where we're sort of fitting in this landscape, I've redone the MAD landscape to be slightly less MAD. So this is sort of a simplified landscape. On the very left-hand side or right-hand side, depending which way you're facing, of the landscape, there's the hardcore data science. This is making the models, this is designing the models, this is crunching the data. This is something which still is, very much dominated by Python or that kind of thing. In the middle of the landscape, there's the business of taking those models that the data scientists build and getting them out so that other people can use them. It's the business of serving models. And so that's where you see something like Hugging Face, for example, is taking the models and making them accessible. And we have a whole bunch of other tools that are in this area as well. So things like Olama, things like Podman AI Lab, things like LangChain. And then we get over to the right-hand side of the model. So for me, as an application developer, this is the bit that's most interesting. This is taking those models and turning them into something actually useful. Because a model on its own is not an application. A model on its own is not solving problems. To solve problems, you need to take that model and put it into a business flow. You need to integrate it to other systems. You need to add the fault tolerance, the resiliency, the security. And that, for us as application developers, is the stuff that we're really good at. This is the stuff that we do every day, and the need for that hasn't gone away. And so for Georgios and me in particular, because our day job is writing Java application frameworks, is writing middleware, those kinds of problems, making that stuff easy is what we've been doing for a long time. And so now we've just extended that out to also be looking at AI. So in terms of what we're going to show today, we're going to show LangChain4j, which again is sort of sitting somewhere between serving the model and the application. And we're going to show it with Java, because we're Java developers. And we're going to show it with Quarkus, because our day job is making Quarkus. So we know Quarkus really well, and it also works best with Quarkus. So, LangChain4j. Now, this is where I will hand over to Georgios.
Cool.
Because he's been doing a ton of work with this for about a year.
Yeah, give or take, yeah. So who here has actually heard of LangChain, like not the 4j part, the Python stuff? Okay, cool, yeah, a few hands. So this was like the original project that like got people, I would say, in the developer world excited about like how they can consume large language models and bring them into, like Holly said, into their applications. But obviously, like this is a very Python-specific library, right? So what happened in the Java world is that people took inspiration from this Python library and started to add Java-specific things to it to make it like much more of a Java idiomatic programming model. Now, I'm pretty sure like similar things have probably happened in other like ecosystems too, like Node or .NET or whatever. But we believe like that the current state of the Java ecosystem and the developments that are coming in the next few years will make like the consumption of large language models extremely easily, and they'll fit in so nicely with the rest of your like enterprise applications, right? Because like at the end of the day, like most people, we write enterprise applications to actually serve customers and bring business value, right? So consuming an LLM is just a detail, right? Like you're not, most of us here are not like database experts, right? Because we don't have to be. All we need to know is like how to talk to the database. Same thing, the same idea is what we're trying to achieve here. So, in the Java world, what you want to do, basically, with just like with everything else, is like you want to declare a dependency. Like you add a specific dependency to your application, and then a whole bunch of magic starts happening, right? For those of you who like don't know what this is basically Java's basic build tool. Like, I shouldn't say basic, like most prevalent build tool, Maven. It has this horrible XML syntax, but whatever. If you're like in a node world, this would be something from the NPM, but anyway, you're just declaring a dependency, right? And then a whole bunch of magic will happen.
And just to go back
Yeah.
to that, what the problem that's being solved there is that you could it's just a REST API when the model is served. You could call it directly and like manipulate all the JSON yourself, but why would you want to when you're in a language that has type safety, when you're in a language that has wrappers that make these things much, much easier?
Right, so maybe we should like actually see what it looks like
Yeah.
in practice. Okay, cool. So I have, at the end of the slides, we will have a link to all these samples here. What I'm going to do here is I'm going to start with, I need to make this bigger for sure. This is absolutely not.
Yeah, your font size is almost as small as the landscape.
And I'm not getting any younger, so it's getting harder to read. Okay, so I think I should also make this white background. I've been told that most people prefer a white background, appearance, behavior, theme, white. Awesome. So can people in the back see this, or should I make this bigger? Excellent. Thank you. So what we're going to do is we're going to start with something that, let's say, kind of resembles like a hello world thing, right? It's not exactly hello world. It's a little more complicated, but we'll explain what we're doing. Now, as we showed in the slide earlier, what we're doing here is we're adding a dependency for LangChain4j OpenAI. So what this application is going to be doing, it's going to be talking to OpenAI. So OpenAI is the company behind ChatGPT, and they also, for our line of work, they provide a REST API. So what Holly said earlier is that you technically don't need like a library to interact with OpenAI. You could consume their JSON, you could send and consume JSON payload on your own if you wanted to, but it gets very tricky. And you obviously don't want to solve the same problem like everybody else has already solved for you. So what we do is we make this super easy. So just by adding this, we are able to talk to OpenAI. Also, they're in the, we have a configuration where you can configure a few things. So in this example, we're like just configuring the temperature and timeout. And there's also a hidden configuration here with my OpenAI key, but that's in like an environment variable, so obviously that's something that's secret, so it shouldn't show up here in the configuration that's checked into the version control. Obviously, because who would do that, right? So we're going to start the application.
I've never done that.
Nobody, none of us here have ever done that. Okay, so we're going to start the application, and I'll show you what the application does initially, right? And then we will go and see how it works. So what it does basically is it's a like hello world style thing that just takes your text and outputs the sentiment of it, right? Whether it's something positive or something negative. So this kind of thing shows up all the time in like business applications, right? Like let's say you're like you have like a marketplace and people like write their stuff and you want to see really quickly like if it's positive or negative, or you could like you want to perhaps in some other cases like filter out stuff like that's abusive language or stuff like that. Large language models make this kind of stuff that even a few years ago were extremely hard to do correctly. Now it makes it like super easy. So let's see it in action. We'll say write a review. You're great, keep up the good work. Now okay, this doesn't seem to scroll for some reason, so let me reset and submit. Let's see, it's going to analyze my review, the you're great. Thank you for your kind words. We appreciate your support. You are terrible. Now, these are like very easy, right? So this should be obviously be Oh, and it responded in French in this case. So that's great, right? This is a great example of why, like, using LLMs isn't always easy, right? Because you don't always get the response you expect, right? And if I try it again, maybe I'll get something better. Let's see. French again. Oh. Let's see. Let's try it in Greek.
I can't tell you how hard it is to not make a joke about French people right now.
Let's see. Okay, so this time I wrote it in Greek, and it replied in Greek, right? And we'll see like how what we actually do to make that happen. But let me make this a little harder. Remember, like when we met like a year or so ago, you said that at one point you were working at IBM and you were trying to do this type of thing. And if somebody phrased it like, while your competitors were terrible, were not good, this product was amazing. I think you said like, if somebody wrote something like this in the past, it would be really tricky for the model to figure out.
Yeah, it would see terrible and it would be like, oh, they're
it.
really angry, they hate us.
Yeah, so let's see. But this time it really knows what you're talking about, right? It has a very, very good understanding of language. So,
except for the not talking in French part.
Yeah. Well, maybe, I don't know, terrible, is that word in French too? I don't know. So let's see what this actually looks like in practice, right? So here's the basic code that you as a developer would write, okay? This is all there is to it. You would write a Java interface. So for those of you who have not seen Java in a long time, interface is basically like a construct where you describe behavior, right? You don't write any actual implementation. You actually describe what the thing is that you want to do. And what we're saying here is like, create me an interface that does triage. So it takes a string, which is a review, a user review, and it returns a response. Now this response here contains two different things. It contains an enum, so a positive or negative enum, and a message where the LLM says like, thank you, or we're sorry, or whatever, right? So this is all stuff we just declared, right? And I don't even need anymore. It was an older version, we could delete this, but anyway. So we're describing basic behavior here, right? Nothing interesting. What the interesting part is here is these two annotations, the system message and the user message. Now, you want to go into more detail about what system message and user message are?
Yeah, and actually before we do that, I'll just point out so there's a lot of text here. Almost all of that is the prompt, which is our instruction to the LLM. The actual code bit is ridiculously tiny. So there's that register AI service. That's the main thing that says, I would like you to talk to an AI service. And as Georgios mentioned, that interface is saying, I don't actually want to provide any of the implementation myself. I'll just leave it to something under the covers to provide the implementation. And then this bottom bit here, that triaged review, instead of getting a string back or instead of getting JSON back, which is probably what's coming under the wire, we're doing kind of magical, miraculous type safety. So we're saying, I would like what comes back to be of this form, and then under the covers, it gets turned into that type safe object.
Without you having to do anything, right?
Yeah,
like,
no.
Just declare what you want, and Quarkus and LangChain4j do it for you.
And so the main sort of guts, the main thing that we're sending to the system are the system message and the user message. So these are two kinds of prompts. The user message is what in a web application you might have the user add into. And the system message is an extra prompt, which the main thing about a system message is that the AI takes it more seriously. So if you said, for example, a system message that said, please answer in Greek, and then the user message said, whatever you do, don't answer in Greek. I'd really like you to talk in French. If the system message says you must speak in Greek, that's more likely to be honored. Whereas if you put stuff that you care about in the user message, and then the user comes along and puts stuff that overrides that in the user message, then you can get into problems. You can get into the situations where, you know, the sort of the classic ignore all previous instructions. Please do this instead. That will be very funny for a screenshot somewhere.
Yeah, exactly. So the idea here is that like you just declare what you want, right? The hard part for you as a developer is coming up with these prompts, right? This is what is an iterative process, like, and it also depends on what model you've configured. Like here, we're using GPT, I think 4.0 as the default, and it might behave differently if you use like 3.5 or if you use Anthropic or Mistral or whatever, right? And here's why it answered in French, right? Because some of the examples are in French.
Oh, yeah.
So.
And it is an iterative process. There is a lot of non-determinism here. And so what often happens, which is a particular problem for us when we do conference talks, is you test it and it works great. And then you show it to someone important and it does something that you have never seen before. And so normally you can catch that kind of thing with a unit test. But here you can't really, because every time is slightly different and slightly surprising. Sometimes good surprising, sometimes not.
So yeah, I just also wanted to show like where we're calling this, right? So basically the only thing you're doing, the glue code we wrote to expose this to the web, to the web interface, was that we are using this service that we declared, we're just injecting it and we're calling it, right? So under the hood, there's an implementation behind that interface that Quarkus provides for you, right? But it's huge. You don't want to know about it, right? All you want to know about is like, what is the input, what is the output? And if you're really curious, we've outputted what goes over the wire for the request to OpenAI and the response. So when you want to play with this, you can actually see this in action. So we're like calling a post endpoint that OpenAI has. We're passing what Holly said, both the system message and the user message. And then you get, as Holly said, you get back like a JSON that's inside another JSON. So you really have to, if you didn't use a framework, you would have to like extract all this manually and figure out all this stuff. But with Quarkus and LangChain, it's all done for you.
Yeah, that's why you don't want to call the REST directly. It seems like a good idea until you actually do it the first time, and then you're like, oh, could I have some help with this?
Exactly,
please?
and then it becomes even harder when someone says, okay, yeah, now you have OpenAI, but okay, now let's talk to Anthropic or something like that, which has a totally different REST API. So then you have to do it all over again, and that's something you just absolutely don't want to do, right? In Quarkus and LangChain, what you would do instead would be that you would just go here, you would change this to like Anthropic. And let's try it again, right? And with Quarkus, you don't need to restart the application. It automatically restarts. It's downloading a bunch of stuff, but the Wi-Fi was good, so we're all good. Let's try this again with Anthropic, and I don't have an Anthropic API key. Well, that's the other thing.
I was impressed that you had prepared enough to have the Anthropic.
So this is the other good thing is that when you use Quarkus, because we've already done like a whole bunch of work for normal applications, right? Like when you're talking to a database and Quarkus doesn't have like a URL or a username password, it will give you a great error message. And all that stuff like automatically translates here too, right?
And so it's a bit like Hibernate, except instead of talking to databases, it's talking to LLMs, but it gives you a lot of those same sort of features. So one is that you don't need to know what's under the covers. You don't need to do the flavor of SQL for the particular database. You don't need to do the API calls for whatever LLMs on the other end. And then also it means that your queries to the LLM and the answers come back in the right language for your application rather than the native language of the database or the native language of the LLM, which is lots of JSON.
Awesome. So should we continue with the slides?
Yeah.
Excellent. Okay.
So far, we've seen the prompts, which is going back and forth with text. And we also saw that we can do the type safety, so you can convert it to the objects. So we've seen that. So we'll share the slides afterwards so you can see the key thing is that register AI service annotation, and then everything else happens by dependency injection. Another thing that will be very useful for you, when you go to ChatGPT on the web, and you ask it a question and you get an answer, and then you give it a minor amendment that says, oh no, I didn't mean you to do it like that, I wanted it like this. What's happening under the covers is that state is being preserved. If you just call it on the REST API, you don't get that preservation of state. But of course, the interaction ends up being pretty terrible without the preservation of state. So with LangChain4j, we've got the support for memory. So there's a default memory out of the box, but then you can also do more complex things. Because of course, if you have an application which is serving multiple users, and one user gets the context of another user, that would be pretty terrible.
That'd be bad, yeah.
So here you can do things like you can have keys into the memory, you can provide your own memory store to give you that more sophisticated partitioning of context per user. So I think, oops. Yeah, you can see here we're passing in a key, and so then that's allowing us to have multiple conversations happening concurrently with different context. But again, still, going back and forth with texts isn't so interesting. You're going to want stuff coming back as objects. Georgios already showed this. You can do much more complex objects as well. Under the covers, this is using Jackson. So in the same way that with a Hibernate ORM, it will use Jackson to convert it into objects. Here, it's taking JSON, then using Jackson to convert it into objects. And if you don't do anything, it will use the field names to figure out what's supposed to be in there. But you can provide descriptions as well. And then that means that it can take user input, which is free text, and convert it into objects for you with things, so here, for example, we're saying the amount in dollars of the transaction. Do you want to show that?
Let's see, do we have that one? Let's see, which one is a good one for that? Chatbot. Actually, well, the one we did basically does have that. Yeah, because it has this record. Let's ignore this. We don't need this. So here we could have added like description. Oops. Description. We could have added a description here, whatever. Because what happens here is that when you're telling the LLM like what to respond with, like Holly said, if you don't give it a description of what each field is, it will use the field name. So you're telling it essentially like, okay, return me a JSON. You use like a JSON schema to define this. But like if this is very generic, then it doesn't really know what to return. So if you add a description, it better understands what it's supposed to do. And in this case of the enum, it actually knew that, you know what, I have to return either positive or negative. If this were like an int, we could tell it like to like give it a score, like between 1 and 100 or something like that. But that's essentially what we did earlier. And for those of you who have not seen Java in a long time, like Java records, right? Java, had always, in Java, everything was a class, so like super verbose, getters, setters, properties, all that stuff. Since, I don't remember, 15, 16, whatever, Java, now you have this record thing, which is a really super concise way of writing stuff, and it saves a lot of coding. And now that all the frameworks and libraries understand it, like everything just works, right?
So having objects is good. Having objects means that your code can take those objects and do things with it. But the old way we might have coded this is that we might have had some manual orchestration that we would have coded ourselves to say, okay, I'm going to take, if the review's bad, I'm going to, whatever happens to the review, I'm going to take the review in, and then I'm going to mail it to the CEO or whatever. Manual orchestration is boring. What we want to get is to a situation where it's a bit more agent-based, where we can declare the actions that are available, and the tool, the system, chooses what action to take. Yes. And what that allows us to do then is really start to get more sophisticated logic into our application without having to write all of the orchestration code ourselves. And the way we do that with LangChain4j is we declare tools. So you can see here we've got this @tool annotation. And I'm saying, what's this tool for? This tool is for sending the given content by email. And so then if my prompt said, write a poem, and then send it by email, without me having to wire in that action, that tool will be invoked if the prompt says, send it by email.
No, let's see this one in action, yeah. We've got 3 minutes. So, let's see. Email me a poem. So what we want to do is what Holly said, right? We want to tell the LLM to write a poem, but not only write it, also send it, right? We want all that to happen automatically. So let's see. Let's see what happens here. Open it up. Okay, write me a poem. Click the button to write a poem. Let's see. It's thinking about it. Oh, and it's very small. Okay, so we'll see in the prompt that this was write me a poem about Quarkus, and it's a whole bunch of cheesy stuff, right? But that's not the interesting thing. The interesting thing is that we want to see that it actually we sent an email, right? So Quarkus does a bunch of things automatically, and in this case, one thing that it did is that because we started it in this special developer mode, it started up a mail server for us automatically without us having to do anything, have to configure anything, right? We set up, it started this mail server, and the reason I wanted to show this to you is that I wanted you to see that the poem that we actually displayed here was sent by the application itself to a mail service, right? The mail service is running locally, but this could have been like an actual like Google Mail or whatever, right?
Let's change the prompt to send it in Greek.
Okay,
and then
let's do it. Let's see, where is the prompt? Okay, samples, email. Okay, so here's the service, right? Write a poem, your response must include the poem, and the poem must be in Greek. Okay, let's see. Now, I don't have to restart. Working. Oh, I should have cleared it because this UI is not the best. Oh, there we go. So we got a poem in Greek, right? Just by, I just like added, like you must reply in Greek. It sent it. Let's see that the UI actually has this. And here it is, right? So I didn't restart anything. I just changed like the prompt, clicked the button on again to send the poem, and everything just works, right? There's so much magic going on behind the scenes here. We could talk about it more. You could find this, and we can answer all the questions you want. We just wanted to show you like how much stuff and how well this stuff ties in, right? And this is an action, right? So what Holly said, there was this tool action, tool annotation, and this is what it is, right?
As Joe just mentioned, you know, there's so much more. So we've just given you a little bit. If you would like to see more and try it yourself, Georgios and Ioannis, who's probably somewhere, are doing a workshop this afternoon where you can have a bit more of a play with it. And there's a lot more features to explore as well. So we've done the tools. We've got support for images that we've just added, so you can do things like images. But we're also, again, you know, because this is going to go in an application, if you're actually going to use this, it's going to go in an application. And then you need those sort of application and qualities of service. So you need things like fallback. So there's fallback. You need things like guardrails. So making sure that the input and the output don't violate your terms of service, or you know, whatever they are, so you can feed those also to LLMs to do checks on them, or security as well. So one of my colleagues has been working on security for this, and he just emailed us all to say that he'd updated it so that you could securely generate a poem about Quarkus, which I love, because I think the need for someone to securely generate a poem about Quarkus is about zero. There is no situation where this is ever needed, but it's kind of fun.
But it's a cool demo, right?
It's a cool demo. And when you're actually doing something serious, you do need the security. And so with that, I think we've got there's a QR code on the slides.
Yes, let's get to that.
So
here we are.
Yep, so if you would like the slides, they're there. If you would like to have more of a play this afternoon, workshop with Georgios and Jonas. And I think, have we got time for questions?
Yes.
Excellent. Thank you.
And we do have some time for questions.
5 minutes, actually.
Okay.
Yep.
Okay, so let's start with the first question. How do you handle the LLM output since its format can be non-deterministic? Any best practices on the applied validations?
Yes, that is a super good question. This is one area where the guardrails are really useful, actually. So for example, sometimes the output is non-deterministic in a funny way, like it's French and you don't know why it's French, but sometimes you get more predictable and irritating non-deterministic variation. So for example, sometimes when you say, give me the output in JSON, I really want the output to be in JSON, it will come back and it will say, oh yes, okay, understood, I'm going to give you the output in JSON, here's the JSON. You're like, no, I wanted it to only be JSON.
Or sometimes it adds the markdown, like the 3 ticks with JSON and then 3 ticks after. So yeah, you have to...
Yeah. And this is where the guardrails can be really useful. So for example, quite often now we're just putting in a guardrail at the end that says, take what comes out. If it's not JSON, because that's easy to detect, you don't need an LLM to detect that, you just have JSON. If it's not, then you can do 2 things. So you can retry, you can say, okay, it was just having a bad day, it was non-deterministic, let's try again. Or you can say, actually, no, let's reprompt because the prompt wasn't good enough. So let me add in a prompt that says, no, I really wanted it to be JSON. So that's one aspect. Then as well, then there's sort of, you do need to rethink your strategy for testing to make sure that you're not going to have really brittle test suites that are sort of looking for keywords that may or may not be there. So you need to sometimes, again, go to the LLMs, even in your testing strategy, to say, okay, well, was the output in line with this prompt? If not, something's gone a bit weird.
All right. Thanks a lot for that. Next question is, how does LangChain4j handle the challenge of maintaining state across different complex interaction flows, and especially when you need to transition between object types?
Right, okay, so this is a large topic. Holly talked about it with the memory. So essentially, you need to use the same memory ID when you're in a user session, let's say, right? If you consistently use the memory ID, the same one, like let's say it's a user ID that you already have, if you use that, like everything will work as expected. Because like Holly said, it's a key to like a database, and then that you can like choose when to delete it or whatnot. But all the stuff that we showed like with the tooling, or Holly talked about the guardrails, all that does interact with the memory, but you don't have to care about it because like the library, the framework handles it all for you, right?
And if you do care, then you can look at the prompt that's going up and you can see your context
Yeah,
in the prompt
that's a
going
great point.
up.
The other great thing here is that when you turn on the logging that we showed earlier, you can see everything that goes to the LM and comes back, right? And that a lot of the times gives you first of all, gives you a better understanding of how things work, and second of all, it's like the ultimate like debugging thing, right? Debugging tool. So this is not like a database protocol where it's like binary. You can't see what's going on unless you're like using like Wireshark with a special plugin or whatever. This is like just text going through HTTP, and you can see what's going on.
All right.
All right.
And one last one.
There was another question on the back. No, it's gone. Now, just 3 are left. Okay. So let's go to the last question. Do you think that a layer to filter the results before showing to the user should happen in order to avoid weird answers? And then maybe try calling the AI model?
That's what you said.
Yeah, absolutely. So definitely when you get past Hello World, you are going to start to need those. And so then this is, again, where the guardrails come in. So you can do all sorts of things with the guardrails. You can do really trivial things like checking if it's JSON, or you can do more complex things like, let's make sure that this doesn't have abusive speech. or let's make sure that this isn't totally wrong. So if you're really concerned about hallucinations.
And it can even use a different model than
Yeah.
the original one you used, right?
Yeah, so you can send the answer from one model to the other model to say, hey, does this check out? And if we didn't talk about RAG, but as well, if you're doing RAG, then you can sort of double RAG as well. So you can sort of do RAG with your first model, and then you can send it to the second model, again, with that RAG context to say, hey, is this correct? Do you want to, we probably have,
Oh, it's not on.
oh, okay.
Yeah.
Oh, we're not sharing. Yeah, okay.
Yeah, I guess you can show them in the workshop, all right?
Yeah.
Excellent.
Awesome. All right.
Thank
Thank
you.
you very much. It's been
Thank you.
wonderful having
Thank you
you
very
here.
much.